Hello, Math 140 students. Let's pick up on page 11, section 3.4, Slope-Intercept Form. The ratio of the vertical change to the horizontal change between any 2 points on a line. So here we want to find the slope of the line given from the graph. So remember what this definition is telling us, that it's a ratio. So the ratio, you really know that can be expressed as a fraction. And it's telling you that the slope is a fraction. So you're saying, okay, so my slope, which is the same as the ratio, is going to be a fraction. And in that fraction, I'm going to compare the horizontal change to the, I'm going to be changing the vertical change to the horizontal change. So my numerator here would be the vertical change. So the vertical change is considered going up and down. And then also we have the horizontal change. In the horizontal change, we can think of what we mentioned, the horizon. So I have my up and down and I have my left and right. So what we want to do, since we want to find the slope, which is we want to find the particular fraction that describes our n value, our slope, and so we can compare it with two different points. So I know that this is going to be my y-intercept. That means directly at those two black lines. So I can think of the next kind of corner of boxes that it hits would be here. So let's think about this. If I start out here, you always want to start going from left to right when you're reading a graph. So when you're reading it left to right, this is where you start, and it looks like to get to the next point, you would have to go down. You would have to go down 1, 2, 3, 4, 5, 6. And then you would walk 2. And that is to your right. So now, if you're talking about the vertical change, that's here. That's going straight up and down, right? Up and down. Well, you happen to go down. Well, since it's down, you know it's going to be a negative, and that's a -6. And you went to the right, and it says you went to the right 2 times, right? Over here, it's 2. So now you know that your slope is going to equal to a -6 over 2. And when you reduce that, it would give you a -3. So m is equal to a -3. So you can say that the slope, which is m, is equal to a -3. That would be your slope of the graph. For example number 2, it's still asking you to find the slope or the ratio. So let's think about these 2 points. Let's think about the y-intercept. That's always a good one if you have it. And wherever it meets at the corner of a box. So it looks like it meets at this corner of the box. I guess it meets along all of these, right? So these all meet in the corner of the boxes. So remember that our numerator, let me try to get my color straight here, green and then blue. So this is going to be my vertical change, and I have my horizontal change. So here I would go up, right, to get to the next one. So it's a +1. So you went up 1, and it looks like you went to the right 1. It's a very small distance that you had to go, but you still have to go. So you went to the right 1, so that's a positive. So you know that your slope, m, is equal to 1. And if you need to think about it, if you look at the fraction, 1 over 1 reduces to 1. Now for number 3, it's slightly different. It's asking what's the slope of this equation. So here, this is a very special linear equation. We've talked about this before, where if we have a linear equation and we have y is equal to some number, that tells us that we are going to have a horizontal line. Another way you can think about it is actually draw it. So if I have 5, I would have here the equation of y is equal to 5. So now that I've drawn it, the way you can think about it, maybe I'll just try to write it a little bit straighter. So it's a straight line. There's no curves and no bends to it. I hope I drew that correctly. So now let's just think about this. What would be the slope of a horizontal line? Well, you can think about it as being a person on this line. And if you walk to the left or you walk to the right, you would see that you would have a 0 incline, right? So you would say that the slope is equal to 0. Now let's kind of look at its opposite. This is saying what is the slope of x is equal to -1. So again, this is a linear equation, but this one is slightly different. This is x is equal to some number. So it's not going to be horizontal, but kind of like its opposite, you can think of it as being a vertical line. So graphically, if you're on this line, then at -1, let's say here, straight up and down, no curve or bend in your line. And if you were a person on this line, if you walk to the left or to the right, what would happen is that your slope would be undefined. Okay? So just know the difference between m is equal to 0 when you have a horizontal line, and m is undefined when you have a vertical line. Okay, so now let's actually use this slope formula. So it says to find the slope through this line. So what helps us is this formula. We just plug it in. That's all we're doing. So we're just like, okay, well, if I have this x2, well, actually, let's just label it. This would be x1, y1, x2, y2. So now we're just plugging in values. So if m is equal to y2 minus y1, x2 minus x1, we would have some values that we are plugging in. And it's a good habit to put in empty parentheses when you're plugging in values, so in that way you can kind of see what's going on. So let's see, for my numerator, I have y2, so that's 7, that's here, and then I have my y1, so that's what I'm going to plug in. So those are the values that I plugged in. Now I'm going to look at my x values. It says x2, well here's x2, and then it says x1, so there it is. So all I did was just plug in values. So now I really just have the equation 7 minus 5 over -1 minus 3. Well, if you put that into your calculator, or if you do it in your head, that's fine, you would get a -1/2. So I know that my slope is equal to a -1/2. One variable equals one number. I'm just going to make sure I write that 1/2 a bit more legible. Good, so that's a 2 underneath that 1. So m is equal to a -1/2. Now I'm going to do the exact same thing. The only difference here is that I have different values. So, okay, I'm going to have my x1, y1, my x2, my y2. So I know that m is equal to y2 minus y1, x2 minus x1, and I'm going to plug in values, and it's a good habit to plug in my parentheses. So my numerator here, y2, that's a -3, and my y1 is a +4. Now I'm going to deal with my x value, so I have an x2, which is 2, and an x1, which is a 2 as well. So then I get that m is equal to a -3 minus 4 over 2 minus 2. So my numerator, -3, -4, I'm going to have a -7, but now 2 minus 2 is 0. So what happens when the denominator equals 0? Well, if you think about this, that means you have nothing, but you share it with, -7 as the numerator. That's how many people you share it with, or numbers, or whatever you want to think about it. And so the fact that you have 0 total and you gave away something doesn't make any sense. So here, this is what you're going to say, undefined. It's not possible to have nothing and share that with somebody. We do know that whenever the slope is going to be undefined, we do know that this is going to be my vertical line. So when it says the slope of a vertical line is undefined, we just did that. And so we know that the slope of a horizontal line, remember, if you're a person and you're walking on this, that's going to have a slope of 0. So there's a huge difference between 0 and undefined. 0's in the numerator for horizontal, 0's in the denominator for a vertical line. Now we want to get familiar with graphing. So it says graph the line passing through this point with this slope. I have my slope. M is equal to a 1/5. That tells me to go up 1 and to the right 5. My starting point would be my B value. So my y-intercept here, or actually, not my starting point is B, but the point that they gave me was x and y. That would be a -1 and a -5. So that is going to be my starting point. So notice how the point that I have, it's -1 and -5. Perfect. So now that I know that, then I can apply the slope here. The slope tells me to go up 1 and to the right 5. I also could have gone down 1 and left 5. So from that starting point, -1, -5, I could have gone down 1 and to the left 5. Notice how the points still line up in a line. So that would be the line passing through the point whose slope is 1/5. Please remember that there's arrows at the end, right? Which means infinite in each direction. The next example, we're going to do almost the exact same thing, just different numbers. So here we have our starting point. It's the point that they gave us. So this is my x value, and that's my y value. So that's where I'm going to start. So I'm going to look at my graph, and I'm going to go to -5, +6. So -5 is here, and +6 is here. So when they meet, oops, so if I have -5, +6, that's going to be my starting point. The next thing I'm going to have is m is equal to -5/6. This tells me to go down 5 and to the right 6. I also could go left 5. Oops. What's the opposite of down? Up. I could go up 5, and the opposite of right is left. So let's think about that. Let's do down and to the right. So I can go down 5. And to the right 6. I also could go up 5 and to the left 6. So we'd end up at the same place. And that's how you graph the line. Now, example number 5. A local road has a grade of 4%. The grade of a road is its slope expressed as a percent. Find the slope of the road as a fraction, then simplify. Well, we are talking about a grade, and the grade is 4%. So maybe if you're like driving, and maybe you're like near a mountain, those are my mountains. Maybe we'll just stick to the road. If you are on the road and you have an incline, that incline has to be measured. So that incline we're going to call the grade. Okay. So the grade of the road is its slope. So I know that the grade is equal to the slope expressed as a percent. Find the slope of the road as a fraction, then simplify. So that means we are going to change the percent into a fraction. So if I have 4%, then you can think of that as a 4 out of 100, because a percentage is always out of 100. And so to reduce that, you would divide both by 2. So then you're going to get 1/25. So now I can say that since I went from a percentage to a fraction, that my m is going to be 1/25. For number 6, it says a mountain road rises 30 feet for a 490-foot run. What is its slope? So that means if we are on, some type of mountain, okay, so pretend that these are mountains. Well, here what we would have is this rises. So rises means up and down. So that means going up, I have 30 feet. Now it specifically says the run. So if I have a run, then I'm going to have 490 run. So I can see that the vertical change is 30 feet. And I have my horizontal change at 490 feet. So if slope represents the vertical change over the horizontal change, then I would have my numerator as 30 and my denominator as 490. So when I reduce this fraction into its lowest terms, I think about 3 divided by 49, and that's going to give me 1 over 13. So I know that my slope is equal to 1 over 13. And so that's going to be my final answer. For example number 7, it says identify the slope and the y-intercept of this line. So whenever I want this slope and the y-intercept, I can think about it as y is equal to an mx plus b. So I want to get that equation and solve for y. So the equation that I have is here, and that's what I'm going to work with. So x plus 2y is equal to negative 2. To get it into y equals mx plus b, I have to isolate the y variable. So I'm going to subtract x from both sides. Then I would have a 2y is equal to a negative x minus 2. Now I can divide by 2, and I can get that y is equal to a negative 1/2 x minus 1. So now I know exactly what the slope is and what the y-intercept is. Remember, when I have y is equal to mx plus b, we know that the m value is the slope, and we also know that that b value is the y-intercept. So the y-intercept is going to be ordered pair where I have 0, b. And so this right here is my b value. It's negative 1. Now, if I'm looking at my slope, that's m, that's going to be the number in front of the x. So that number is a negative 1/2. So now I have my slope, and I also have my y-intercept. For example number 8, it says use the graph to find the slope and the y-intercept of the given line. Compare the values to the equation y is equal to 3x minus 3. Well, let's think about this. I know that my y-intercept is here. So that tells me that's 0, negative 3. B is equal to negative 3. Now let's think about our slope. Well, I can think of that being my next point that I'm looking at. So I would go up 1, 2, 3. So up 3 and to the right 1. So I would have my slope as up 3, right 1, which gives me a 3 over 1, which is the same as just a 3. That's exactly the same of what I have here. I have my b value, which is negative 3, and I also have my slope value to be a positive 3, which is exactly the same. So So that line is graphed down below, or you can say it has the same y-intercept and the same slope. There's a lot of different ways of how you can state that. But you can see it's the exact same line. This is y equals 3x minus 3. For example number 9, we also want to graph this equation. So we know that when we have y is equal to mx plus b, that we have our b value. So b is equal to negative 2. So my y-intercept is 0, negative 2. So on this graph, 0, negative 2, that is my y-intercept. So we can see that our slope, m, is equal to negative x over 3. So it's almost x. It's almost our slope, but the x is kind of tripping us up. This is actually the same as a negative 1 over 3 times x. So now I can really say that m is equal to a negative 1 over 3. So the slope tells me to go down 1 because it's negative, and to the right 3. Or I can go up 1 and left 3. That also works. And so that would be my graph. For example number 10, what's different about this one is that you don't really have it given to you in that nice y equals mx plus b. So we're going to have to work for it. And the way we're going to work for it is to make sure that we isolate the y variable. So remember, our goal, like why are we even doing this problem? Because we want to graph y equals mx plus b. Because that's the easiest. It tells us the y-intercept and it tells me the slope. So here I have my 3x plus 2y is equal to a negative 2. The first thing I'm going to do here is subtract a 3x from both sides. From there I'm going to have a 2y is equal to a negative 3x minus 2. And then don't forget to divide everything by 2 to get the y isolated, so that y is equal to a negative 3 halves x minus 1. So now I know that my y-intercept is 0, negative 1, and my slope is to a negative 3 halves. So my slope tells me to go down 3, to the right 2, or up 3, left 2. And so that's my graph. Number 11 reads, Costa is planning a lunch banquet. The equation models the relation between the cost in dollars of the banquet and the number of guests G. Interpret the c-intercept of the equation. So maybe the language is difficult because it's not in what we would normally see. And we would normally see it in y is equal to mx plus b. So the fact that here we have something that's slightly different because the variables are different, it really does kind of represent the same essence of that linear equation. So I really had that c is equal to 450 plus my 28 grams. Well, to make that equation look more like the y equals mx plus b, you can think of the m value here being 28. That would be your rate or your slope. So I'm going to rewrite this as c is equal to 28 grams plus 450. So like I mentioned before here, the 28 is going to be how much it cost per guest. And remember that b value is your y-intercept. And if you have your y-intercept, then that you can think of that as that being your initial fee. So that's how much it's going to cost, let's say, if you have 0 guests. So now you can think of this as, writing this as a sentence. So you know that C is the cost in dollars. So the cost is equal to the equation of $20, which is the cost per guest. So the cost is going to equal the cost per guest plus your initial fee. Maybe you can think of that like your deposit or something like that, right? It's just to hold the spot and have it, to hold the venue if you're having some type of an event like a party, maybe a wedding or a quinceañera or, something else. Just to hold that place, you have your initial fee. And here that initial fee is $450. So let's think about what this actually means in English. Here are my my choices. The C-intercept is 28. No, the intercept is actually 450. So the fact that it says the intercept is 28, that would be incorrect. So just seeing that eliminates 2 of my choices. So now we definitely know that the y-intercept is 450. We said that here, right? That is the C-intercept. So now I just have these 2 to worry about since it has the C-intercept as 450. Now, is this the amount of dollars the banquet would cost if there are no guests? Or is this the amount of dollars the banquet would cost if there's 28 guests? Well, the fact that I specifically say that's going to be the cost per guest, then that 450 would represent no guest, just to hold the spot. So I'm going to have that this is going to be the best answer. That is the best selection. That the C-intercept is 450, and that means that there would be 0 guests. Now getting into our parallel and perpendicular lines. We know that 2 lines are parallel if they have the exact same slope and different y-intercepts. Perpendicular lines mean that they meet at a 90-degree angle. So visually we have parallel lines, they just look like 2 lines that are facing each other. And we have those perpendicular lines where they actually intersect and that meeting point. And the really cool thing about their relationship is they actually meet at an intersection of 90 degrees. So that's very, very particular. So we go ahead and label that as perpendicular lines because they meet specifically at that 90 degrees. So we want to know whether or not these lines are parallel, perpendicular, or neither. So if this is the case, what it's really asking us to look at is the slope. So look and compare slopes. That's what it's telling us to do. So you're just like, okay, well, let's figure out the slopes of both of these equations. So if we have equation number 1, then I'm looking at y is equal to x over 2 plus 5. And then don't forget to look at equation number 2, which is this x minus 2y is equal to 3. Well, for equation number 1, what we can do here is we can rewrite it as a 1/2 x plus 5. Notice how it's a little bit easier to see the slope once I pulled that x off. So this tells me that my slope is equal to a positive 1/2. That's from equation number 1. From equation number 2, I have to work on this. I have to subtract x from both sides. So that negative 2y is equal to a negative x plus 3. divide everything by a -2, so that y is equal to a positive 1/2 x minus a 3/2. So here my slope, that's the only thing I'm looking at, is the slope. So here the slope in both cases are exactly the same. So what is their relationship? Between the slopes of these two equations? Well, you see that their relationship is exactly the same. So comparing the first slope and the second slope, they are exactly the same. So we can conclude that these lines are parallel. If I can spell it correctly. So we checked the slopes and they turned out to be parallel lines. Let's try this again. So I have my first equation as a -3x minus 3y is equal to 1. And I have my second equation here as a -3x minus 4y is equal to 5. So solving for y, I am going to add 3x to both sides. I would get a -3y is equal to a 3x plus 1. Divide by a -3. So that here y is equal to a -1x minus 1/3. So I'm looking only at the slope, and this slope is a -1. Now I'm going to find the slope for my second equation, or here it happens to be green. So I'm going to add 3x to both sides. So that -4y is equal to a 3x plus 5. Now I'm going to divide by -4. So that y is equal to a -3/4 x minus 5/4. So I'm looking now at this slope. This slope tells me it's -3/4. So let's compare or see the relationship between these two slopes. Well, they're not exactly the same, and they're not perpendicular because it's not the opposite reciprocal. So not parallel, not perpendicular, so it must be neither. So looking at number 3, again, I have my two equations. So I'm just going to compare them. So I have the first one. That's going to be an x minus a 7y is equal to a -6. So I'm going to go ahead and subtract x from both sides. So that -7y is equal to a -x minus 6. Divide by -7. So that you can get that y is equal to a positive 1/7x plus 6/7. Looking strictly just at the slope, m is equal to 1/7. If I'm looking at that second equation, I have a -7x minus y is equal to 2. So I'm going to go ahead and I'm going to add 7x from both sides. So I can get a -y is equal to a 7x plus 2. Then I'm going to divide by -1. So that y is equal to a -7x minus 2. Now I'm going to get that my slope is equal to a -7. So what do we want to do? We want to compare these two slopes. So let's think about this for a moment. We have 1/7 and -7. So the slope from the first equation was a 1/7. we have the equation, or the slope, of the second being -7, or better yet, -7/1. So they're not exactly the same, but there's definitely a relationship here. They are the reciprocal. So that means it's, flipped. So 1 from the numerator is now the denominator, and 7 in the denominator is now 7 in the numerator. And it also has the opposite signs. So one is positive and the other one is negative. So this is positive and negative. So they're reciprocal and opposite signs, so that tells me that these are going to be perpendicular. So now I have my answer for number 3 being perpendicular. So for number 4, remember our question is whether or not these lines are parallel, perpendicular, or neither. So that's what we're trying to figure out. So we have our two equations. We have y is equal to 1, and our second equation is x is equal to 4. Well, remember that this is a horizontal line, which tells me that the slope is going to be 0. Versus for number 2, this tells me that this is going to be a vertical line. So my m is going to be undefined. So since my slope is 0 and undefined, it might be the easiest to be like, well, they're not quite the opposite and reciprocal. It's not really exactly the same. What is actually going on? So it might just be easier to give yourself a visual representation, which is fine. So I have 1, 2, 3, 4. So x is equal to 4 will look something like this. And I have my horizontal line of y is equal to 1. So y is equal to 1, that's going to look something like this. So let's see, are these, that purple and green line, is it parallel, meaning they don't intersect, or they do intersect at a perfect 90-degree angle? Well, I can tell you that this is actually a perfect 90-degree angle. So yes, these lines are going to be perpendicular. So that's going to help us think about number 5 here. So maybe we want to graph this instead, right? So here we go. This is my x value, here's my y value. So x is equal to -2. Here's x is equal to -2. Now I'm going to have x is equal to +9. So what do these graphs look like to you? Well, to me, they look parallel. So these lines are going to be parallel. For the next problem, it says, write the equation of a line that passes through the given point and is parallel to this given line. So, okay, we want to write something that's new. We want to write a line. What does that line look like? Well, it looks like y is equal to mx plus b. Okay, so what can this parallel line tell me? Well, it can tell me the slope for the new equation. Because if it's parallel, it means to have the same slope. So I'm going to inspect the equation. So I have the 2x plus y is equal to 5. What I'm trying to find is find slope to write new equation. So that's what I'm going to have to do. So I am going to subtract 2x from both sides. So I can get that y is equal to a negative 2x plus 5. So here my slope is negative 2. So since it's going to be parallel, that's what it said, parallel over here, so I know that my new slope would be exactly the same as m is equal to a negative 2. So now I'm trying to write the new equation. So finding that new equation, well, I have y is equal to mx plus b, that's the general formula that we just plug it into. So I have y is equal to, and that m value that we found was a negative 2. So now what I have to do is I need to find the b value. Well, I'm going to find the b value by plugging in this x and y. So x is equal to 2 and y is equal to a negative 3. So my equation, y is equal to a negative 2x plus b. I have my y, I have my x, I'm trying to figure out my b value. So the y value I'm plugging in is a negative 3, the x value that I'm plugging in is a positive 2. So negative 3 is equal to a negative 4 plus b. If I add 4 to both sides, 4 minus 3 is 1. So now I have found my b value. So now my new equation is given by the following. Y is equal to negative 2 x plus 1. That's what it means to find the equation of a line that is parallel we're going to take that same thought process and think about that of how to write the equation of a line that passes through the given point and is perpendicular. So here, if something is perpendicular, it has to fit two criterias, right? One, it has to be the reciprocal slope. And the second is that it has to have opposite signs. So we get that by looking at my original equation. So we're going to use this old original equation to find the slope for the new equation that I'm trying to find, since we know the relationship between these two lines is that the slope is going to be the reciprocal and the opposite sign. So here I'm going to have my original equation. And remember, the reason I'm looking at it is to compare slopes. So I have my 2x minus 5y is equal to a positive 10. So I'm going to subtract 2x from both sides. So that negative 5y is equal to a negative 2x plus 10. From here, I'm going to divide by a negative 5 everywhere. So that y is equal to a positive 2/5 x minus 2. So then from here, let's look at the slope, right? It's perpendicular. So here, my slope is 2/5. What do I want? I want it to be perpendicular. So then my new m, well, I know it has to be the reciprocal, so I'm going to have to flip this fraction to be the 5/2, and it has to be opposite sign. So if it's positive, now it's negative. So now I have to find my b value for my new equation. But I already have my m value. So y is equal to mx plus b, but I know that that new m value is a negative 5/2. And to find that b value, I'm going to use my x and y here. So then here, all we have left to do is find the b value. So remember, this is what I'm looking for, my b value. So I'm going to plug in my ordered pair -3, -1, which tells me that x is equal to -3 and y is equal to a -1. So I have y is equal to my -5/2 x plus b. So that y value that I'm plugging in is that -1, and the x value is -3. So now I have -1 is equal to a positive 15/2 plus b. So I'm going to subtract on both sides. So then b is going to equal to a -17/2. So I have my equation as y is equal to a -5/2 x minus 17/2. So when it says to write the equation of a line that passes through the given point and is perpendicular, this is what it means. All right, thank you guys.